We are going to start chapter 5, which is about ratios, rates, and data analysis. And today we're going to cover lesson 5.1, which is about ratios. Okay, so let's first define what a ratio is. A ratio Okay, a ratio is a comparison of two, I probably should put different quantities. I'm sorry, a comparison of two quantities using division. They are not different. Okay, so there's three ways that we can write ratios. And you are going to need to know all three of these, okay? Because they can present them to you in any of these ways. So you're going to have to know what they look like and understand what they mean. Okay, so the first way we can write it, it looks like a fraction. Okay, so if we were to say 3/5. Okay, so hopefully maybe you're asking yourself, well, Mr. Fisher, how do I know whether that's a fraction or a ratio? Because that's a great question. Well, the answer is you have to read the problem carefully and see what they're asking. That's the only way that you can tell the difference between whether that is a fraction or whether that is a ratio. Number two is a semicolon. Okay, so we can write this 3 semicolon 5. Okay, we substituted in a semicolon where the fraction bar goes. And the last way, number 3, is to write the word to, T-O. 3, 2, 5. Okay, so those are the three ways that you can write it. Write a ratio as a fraction, 3/5, using the semicolon, using the colon, 3:5, or using the word to, 3 to 5. Now, what I want you to notice out of all of those examples is there is an order to ratios. Notice that the 3 is first and the 5 is last. Okay, and we've talked about this before in the first 4 chapters. We read math going left to right. Okay, well, this is very important when it comes to ratios. Whatever is first is first. It either goes on top of the fraction, in front of the colon, or in front of the word to. If you switch one of these and say 5 to 3, that is incorrect. Okay, based on the question that was given. Okay, so there is an order. Okay, whatever is first comes first in the ratio. Whatever is last comes last in the ratio. Okay. Simplifying ratios. Okay, very similar. Could be, you could say it's the same thing as reducing a fraction to lowest terms or simplest form. Very same concept. Okay, so for example, if we have a ratio that is 600 over 540. Now, what I don't want you to do is to turn these into mixed numbers. These are not numbers. Okay, something on top is represented by 600. Something on the bottom is represented by something else. So this could be 600 girls to 550 boys or 540 boys. Okay, so we're not turning these into improper fractions. Okay, they either stay as a fraction. You can write it using the colon, or you can write it using the word two. Okay, so if you notice, maybe we can divide by 10 here, right? Because it ends in 0. So we would get 60 over 54. Okay, that's reduced. That's not in simplest form, right? So again, hopefully we know our facts. So we can recognize that we can divide by 6 again. And we're going to get 10 over 9. Okay, and at that point, that's all the farther you can go. It's no different than if we were reducing a fraction to simplest form. Okay, now we did that in 2 steps because that was a big number, 600 over 540. Okay, if you recognize possibly that you could divide by 60, okay, then you would automatically get it down to 10 over 9. Again, back in chapters 2, 3, and 4, we mentioned something called the GCF, the greatest common factor. And again, if you know your facts and your factors, right, if you use the largest one, you will automatically get a fraction in simplest form. Okay, that's not a requirement, but again, if you use the largest numbers, if you can think of the larger numbers that go into them, you can get down to simplest form very quickly. Okay, so you're going to have to be able to simplify ratios, which we've already done this, like I've said. Okay, when we've dealt with our fractions in chapter 4. Okay, equivalent ratios, again, is very, very similar to equivalent fractions. Basically, it's the same skill. Okay, but again, we're dealing with ratios that look like fractions. And again, the only reason or the only way that you would know that the difference between a fraction and a ratio is by reading the question. Okay, so if we have 4/12, okay, because if they ask for 2 equivalent ratios, you can either multiply or divide, okay, depending on the original fraction they give you. Okay, so if we noticed that we could divide by 4 here, one equivalent ratio would be 1/3. Okay, that would be one equivalent ratio. If we needed another one, okay, we could come back here We could multiply by 2, right? And I highly recommend you multiplying by 2s and 3s or dividing by 2s, 3s, and 4s, whatever the numbers allow you to. Okay, so if we do that, then we can get 8 24ths. That would be an equivalent fraction. I'm sorry, an equivalent ratio. Okay, or even if, let me rewrite this again for you over here, 4/12ths, and maybe you recognized that, hey, I can divide by 2, which is perfectly fine. That would be a third one. That would be equivalent to the original one of 4/12ths. Okay, so this shouldn't be anything new to you. We did this in chapter 4. Okay, so we just changed the word ratio, okay, from fractions, but there are labels associated with these in problems. Okay, I'm just not putting them down at the moment because the skill is the same. Okay, another one, if we had 7/14ths, right, same thing. I'm sure that you could recognize that we can divide by 7 and get 1/2. That would be 1 equivalent ratio. Okay, now there's nothing else you can divide here. So again, like I said earlier, the easiest thing to do, use small numbers, okay, because as you know, the larger numbers that we use, the more difficult it gets. So we could have 14/28. That is a second equivalent ratio to the original one, 7/14. Okay, so you're either going to multiply or divide. That should not be anything new to you. Okay, that's kind of like almost like a refresher from chapter 4. Okay, and the last thing here that we need to talk about, at the end of some of the problems, it's going to ask you to explain what the ratio means. Okay, that's going to be the words. That's what it's going to say at the end of some of the questions. Okay, so if we have a problem that looks like this. Now, I know you haven't seen these yet, but they use a lot of pictures, pencils, erasers, frogs, animals, cars, bicycles, you name it, shapes in this case. Okay, so they use anything. Okay, they'll use two objects. Okay, because we are comparing, as we said earlier, two quantities using division. Okay, so you might ask yourself, well, which one comes first, the squares or the triangles? Well, as we said earlier, we read left to right, right? So the squares are coming first. So if we were to write this ratio 3 different ways, that would be 4/3. 4/3 is a fraction. 4:3 and 4/3. Okay, notice that the 4 comes first because we're reading left to right, and the square comes first in the picture. Okay, if they were on top of one another, okay, so let me show you that example. So again, same 4 squares, And we would have the triangles down here. Okay, that's no different. If we were to draw a line there, again, how do you read a fraction? You read it from the numerator to the denominator. Okay, so again, all of these would still apply. Okay, because sometimes they're not all in a horizontal line. Sometimes they're on top of one another. Okay, all right, but the bottom line is you need to read the question carefully. Okay, and they will tell you what comes first and what comes second. Okay, whatever you read first is first. Okay, so back to our question here where it said explain what the ratio means. Okay, so when you write the words explaining what these ratios mean, these are the words that you have to write down. This is how you express what this means. Okay, so you would write for every 4 squares, there are 3 triangles. Okay, I wish I could explain to you why. I honestly do not know. For every however many, right? And then you would write, maybe that's turtles, maybe that's birds, maybe that's lions. Okay, for every however many shapes that you have, and then you would list what it is. There are, again, you would list the number and whatever shape, item, animal, object, whatever that is. Okay, for every 4 squares, there are 3 triangles. Okay, so the key words here, obviously, that goes in front of the first one, that goes in front of the second one. Okay, and that ends lesson 5.1 about ratios. It's fairly simple. Okay, we're starting off slow here. Just to give you a heads up, lesson 5.2 is going to be about rates. That's a lot more involved. And then in 5.3, we're going to be solving rates, where you need to know a few formulas. Okay, this ends lesson 5.1. Good luck.